the results from the shake flask, the first one basically shows the pH levels. And we collected the pH levels over 21 days. And I chose one set of the data because most of the graphs showed the similar trend. And for the presentation, I just chose one set of the lab work. And this one shows the pH going from 2 all the way to lower than 1. And this basically confirms that sulfate ions are being produced within the reaction. So the reaction's taking place, the sulfur is not affecting the thiobacillus thioxidin species, which oxidizes the sulfate, elemental sulfur. So this is a check to confirm that the bacterial activity is not inhibited. Another check on this is the oxidation reduction potential. And once again, you can see the levels go down, and this shows that the oxidation did take place, and that both the thiobacillus thioxidin and the peroxidin were able to do their oxidation reactions. And the final check is to count the actual bacteria and see if bacterial growth is affected by this process by adding waste-side sulfur. And all the graphs did show a steady increase, especially the ones with adding sulfur, which is what we were concerned with. And this set of data is collected from the sample with both raffinate modified medium and the sulfur added, and also the mesophilic range. So you can see how the bacteria is growing, and the sulfur added is not affecting it. So this is just a way to prove that the sulfur is not directly affecting the bioleaching process. Moving on to the third set of tests done is a column test procedure. And what we took here was 8 different columns marked like that. And this diagram basically describes what we did. We take a sample of raffinate, which is the sulfuric acid with ferric ions, from the heap and from the mines, and then we run it through a pump, and it goes into this column packed with the copper ore chalcopyrite and also the sulfur added in this table. The first 2 columns are treated as a control column, and the others are added increasingly, and the last 4 have 5 pounds of sulfur added to it. And then the POS, or the pregnant leach solution, is collected at the bottom, and that's tested every day for different values, and that's what we compare to get our final results. But this test is ran for 137 days, and so we get a better idea of what the heap conditions are, because in the heap also we're looking at a 4-month period of one heap before we move it over and start a new one. And these once again are the ID numbers. Keep in mind the first 2 are your control, and the rest of them has sulfur added to it. And the last 3 have some variance in nutrients added, since the bacteria grows naturally. Once you add nutrients, it naturally grows within it. But then you add biomass just to confirm that there is bacteria present. And this will give us a good check to see how the whole procedure would work. Now, looking at the results, once you compare the cumulative copper percentage recovery against the number of leach days, you can see how all of them show an increase, but there's a definite difference between these 2 and these 2. And the bottom 2 are 168 and 169, which are your control columns without any sulfur added to it. And everything above it are columns with the sulfur added. So looking at the graph, you can tell how there is a increase in the amount of copper recovered as the sulfur is added to the column. And the control columns just verify that. But looking at the next graph, which is acid consumption with the number of leach days, it shows the opposite, where your 2 control columns, 168 and 169, are consuming more acid compared to the other columns which have sulfur in it. And this is a good thing that it's consuming less acid, because we have to replenish the sulfuric acid within the system, so the less amount of sulfuric acid we have to replace, the less expensive the overall process is. So this test right here confirms that adding sulfur is beneficial to decrease the amount of acid consumed. Bringing it all into dollar figures, we look at the net economic value, and what it does here is we take the price of copper and look at the amount of money generated, the profit from the copper recovered, minus the amount of the money spent in consuming acid. And the difference is termed as net economic value. And once again, if you look at it, the 2 control columns are at the bottom around $6 per ton, and all the other columns are above that with the potential of being up to $8 per ton. See, we're looking at a $2 per ton difference, and $2 doesn't look like much, but when you're talking about 40,000 tons per day, it does amount to a lot.
Well, $6 of what exactly? I mean, per ton of what exactly?
The
Is that
$6
per ton of?
the copper ore within the heap.
Okay.
And, I'm sorry, not the
No,
ore,
wait.
but the acid being pumped through, the raffinate coming through the leach.
Okay.
So, on top of the heap, we got the raffinate leaching it, and so we look at that, and you take the copper being produced, the price of that, you take the price of acid that we have to replenish as it's consumed, because that would be a cost and a profit, and the difference is what's being plotted here.
Okay, so it's a difference here. So that's the one thing when I was reading this, I couldn't quite figure out per ton of what that $2 difference really meant, I guess.
Okay.
Okay, and so, but it sounds good, I know, but I wasn't sure per ton of ore produced, or is that what it amounts to?
It would be the per ton of acid being used, because
Per ton of
we're
acid.
dealing with 40,000 tons of acid going through the system.
Right.
So that's what we're looking at. The raffinate, at the end of the day, is what we're looking at.
Okay. All right.
And based on these values, we looked at the 3 different tests of metallurgical analysis, which identified all the different components. We looked at the shape class test, which confirmed that the biological activity, the bioleaching, is not inhibited. And then we looked at the column test, which showed an increase in profit. And the problem statement, once again, is the activity being hindered, but we're seeing results the opposite, contrary to that. And the environmental side of the whole study is that now we don't have to worry about shipping it off as hazardous waste. We can just put the wayside sulfur back on the heap, and you don't have to pay the extra fee. And when you're talking about $300 per 55-gallon barrel, that amounts to $162,000 a year in terms of saving money from the disposal fee, now that we can just dump it back in the heap. You're saving in labor, now that we don't have to document all these barrels going to EPA and transportation, since we could just bring it back to the mine. And financially, that money saved from the disposal fee is adding on to the money saved in the net economic value. So overall, I would recommend the company to start dumping the wayside sulfur back on the heap, since it is a good way to recycle the sulfur being lost, and also it saves the company a lot of money. And these are my references.
And we were talking about this the other day, just for a minute, but you didn't really tell them yet, these results? They don't?
No, I need to
They don't?
write up a formal report and send it to them.
Okay. This is not the formal report then?
No, it wouldn't be, because they have a different set of procedure going,
Right.
but I could use the same data to send it to
Right.
them. I just have to reload it.
May I ask, what's mesophilic and moderate conditions? You said temperatures, but
Yeah.
what does mesophilic mean?
Mesophilic, from what I've looked up, I find out that the bacteria found in this case, the bacteria within the heap are classified as thermophilic, which means they grow in the heap. So mesophilic is that category of that temperature range that it grows in. So they distinguish it down to that set temperature. And the reason why we did both moderate and mesophilic is within the heap we had bacteria that were a mixture of both. So we wanted to test for both moderate and mesophilic temperature ranges to make sure we're testing the sulfur against all the bacteria we're concerned with. Because within the heap, it's a mixture being grown naturally, but we're worried about just the thiobacillus species.
You know, I wondered about that too, and I thought, in this heat, and you don't really talk about this, does it heat up in there?
They do have like air supply going in.
Yeah, I know,
And,
but still, all those reactions and things, I would assume that it would heat up in there, it would be warmer in there. Is that right?
It is, and
And
that's
the
how
bacteria like that then, they
Yeah.
like the warmth.
I did
Okay.
see a pattern while I was looking at patterns for the mine where one company did implement heating up the air